Hey everyone, and welcome back. We're diving deep into AI today, specifically autonomous agents.
Oh, yeah, those digital butlers we've all heard so much about.
Exactly. Think someday maybe they'll be sorting our emails, ordering groceries, all that.
Hopefully without causing any trouble.
Right. No digital drama. Our guide is this fascinating research paper. It's called AndroidLab Training and Systematic Benchmarking of Android Autonomous Agents. And to help us break it all down, we've got our expert here.
Well, I'm happy to be here. It really is a fascinating area of research, and this paper does a great job laying out a framework, not just for training these agents, but also for, figuring out how well they're actually performing, because of course we want to be able to trust them
Yeah.
before we hand over control of our digital lives.
Exactly. So where do we even begin with something like this? What exactly is Android Lab?
Okay, so Android Lab, it's not a physical lab.
Not robots swiping on phones.
No. No robots. It's all virtual. Think of it like a simulated environment where researchers can test these AI agents on Android devices, uh, you know, without any risk of them doing something they shouldn't.
Like accidentally posting on social media.
Exactly. Yeah. So this simulated environment, it's really important because it lets the researchers test different agents under, the same conditions, so they can compare their performance pretty fairly.
So it's like a training ground. But why Android? Why not iPhones or something?
Well, a couple reasons. One is that Android is open source, which means that researchers can really dig into the code and see how the AI is interacting with the system, at a much deeper level. Plus, well, Android phones are everywhere. So the impact of a successful AI agent for Android could be, well, huge.
That makes a lot of sense. Now, the paper talks about something called operation modes. This is how the AI agents interact with those phones, right?
Exactly.
And they mentioned two main modes, one for text-based AI and another one that's for AI that can work with both text and images. Can you tell us more about those?
Yeah, so it's a really smart way to test different types of AI. So the first mode, it's all about language. So the AI gets a textual representation of what's on the screen, and it has to figure out what to do based on that.
Okay, so it's basically reading the screen.
Yeah, kind of like we would, but just in a format that it can understand.
Yeah.
So this is perfect for AI that excels at understanding language, like those chatbots that you see popping up everywhere.
Makes sense. What about the other mode? How does the AI actually see the screen with images?
Yeah, so the second mode is called set of mark, or SOM for short. And this is where it gets really interesting because it allows researchers to test AI that can process both text and images.
More like how we do it.
Exactly. So the AI gets a screenshot of the phone, but instead of having to analyze the whole image, all of the clickable elements are labeled with numbers. So the AI can choose its actions based on both what it sees and, what the text on those clickable elements says.
That is really interesting. It reminds me of those choose your own adventure books.
Yeah.
Yeah, exactly.
So how do they actually measure how well these agents are doing? Is there a grading system?
That's where the benchmarking comes in. So the researchers, they created a set of tasks, 138 to be exact, across 9 popular Android apps. And we're not talking about, simple stuff here.
Yeah.
These AI agents are dealing with setting alarms, adding contacts, sorting music playlists. They even have to figure out how to get from point A to point B using an offline map. It's like it's a digital obstacle course.
That sounds pretty intense.
Yeah.
So how do they score them? What are they looking for?
Well, first there's the success rate.
Yeah.
Right. Did the agent complete the task or not? But they also dig deeper. They break the tasks down into smaller steps and look at how the AI does on each one. Because even if you don't get the whole thing right, doing some of the steps correctly, well, it shows you're at least on the right track.
Right. You get partial credit.
Exactly.
Yeah.
So, it's not just about pass or fail. It's also about understanding how the AI is thinking.
Makes sense. What other metrics did they use? Well, they also looked at how efficiently the AI was working. So, did it take unnecessary steps, kind of like a human fumbling through menus? And they measure this using something called the reversed redundancy ratio. It basically compares the number of actions the AI took to, the number a human would take for the same task. So a higher ratio means the AI is, more streamlined, less wasteful.
Okay. So are there any other metrics that they're using?
Yeah, one more that's really interesting is the reasonable operation ratio. And this one tells us, what percentage of the AI's actions actually resulted in a change on the screen. Because sometimes, an AI might just tap randomly. even if it doesn't help with the task. So a high reasonable operation ratio means that the AI is making, purposeful choices,
Hmm.
not just tapping around.
So they're looking at if it's actually thinking about what it's doing.
Exactly.
Got it. So we've got the testing ground, the tasks, the scoring system. What did they find? Who's winning this digital butler showdown?
Well, the results, they're fascinating, and they really show just how competitive this field is. And you know what? It may not be what you expect.
Oh, now you've got to tell me. Don't leave me hanging.
All right, all right. Let's dive in. So the top performers, they were, unsurprisingly, models from Google and OpenAI.
I figured.
Right. They achieved some really impressive success rates, but then things get interesting.
Okay. Tell me more.
The open source models, at first, they were like way behind. But then the researchers did something really cool. They took a huge data set of real-world Android usage data, and they used it to fine-tune those open source models.
So they're giving the AI a crash course in how humans actually use their phones.
That's a great way to put it.
Yeah.
Yeah, they called this the Android instruction dataset, and it contains a ton of data, over 10,000 sequences of actions and 94,000 individual steps. And the results of this fine-tuning, they were remarkable. Those success rates for those open source models, they just shot up, putting them much closer to those, industry giants.
Wow. That's impressive. So did this instruction tuning impact those efficiency metrics that we were talking about before?
Oh yeah, not only did it improve the accuracy, but it also made those open source models much more efficient. For example, one model saw its reasonable operation ratio go from just 18% to a whopping 85%.
So from random tapping to actually focused actions.
Exactly.
Wow. Okay. So even though those closed source models from those big companies still have a bit of an edge, it sounds like open source AI is catching up really fast, especially with this instruction tuning. It's a good sign.
Yeah, absolutely. And it really shows the potential that open source AI has. And the fact that it's, narrowing the gap so quickly, that's a testament to all the creativity in the research community.
For sure. Did the researchers find anything else surprising during their, experiments?
Well, actually, there is one thing. It turns out that the size of the virtual phone screen actually affected how well the AI agents did.
Wait, how could screen size matter to an AI?
Yeah, it seems strange, right? But the researchers, they found that the agents did best on screens that were, kind of the size of a typical smartphone. When they tried smaller screens, the AI had to do a lot more scrolling around, which I guess made it harder to find things. And then when they used larger screens, especially in landscape mode, it kind of messed things up because the layout of all the elements was different.
So basically, they're running into the same issues that we do when we're using different devices.
Exactly. And that suggests that even though these AI agents are digital, they're still, in a way, bound by the same kind of constraints that we experience in the physical world.
That's a fascinating thought. It highlights how complex it is to create an AI that can understand and navigate our technology, the same way we do.
Exactly. It really shows that, even something that seems as simple as a smartphone, well, it can be pretty challenging for AI to fully understand.
Yeah. We definitely take it for granted, but I want to zoom out a little bit. What are some of the big picture takeaways from this? What does it mean for the future of these, autonomous agents?
Well, I think the biggest thing is the rise of open source solutions. The fact that those models are getting so good, especially after being fine-tuned with that human interaction data, well, it shows that we don't necessarily have to rely only on those big tech companies to develop all of this.
That's really exciting. It feels like it opens up a lot of possibilities.
Absolutely. When more people can contribute to AI and benefit from it, well, it just leads to a more diverse AI landscape, and that's a good thing.
Now, I have to ask about the ethics of all this. I mean, we're talking about AI that can access our devices, our data. It's kind of scary.
I understand. It's definitely something we need to think about. And the researchers, they do acknowledge that in the paper. As these agents become more capable and more integrated into our lives, we're going to have to be very careful about the ethical implications.
So how do we make sure these digital butlers, don't go rogue? Do we need some rules?
I think it's more about building a culture of responsible AI development. And that means having these conversations about privacy, security, transparency, and accountability.
Yeah.
We need to make sure that AI is helping us, not controlling us.
So finding that right balance between convenience and, still being in control.
Exactly. And that's where the idea of explainable AI is really important. We need to be able to understand how these agents are making decisions, what data are they using, why are they taking certain actions. And the researchers, they actually explored this in the paper. They looked at two frameworks called React and SEACT.
Okay, now those names sound familiar. Tell me more about them. How do they make AI more, explainable?
Okay, so React, it's all about encouraging the AI to think out loud. So it prompts the AI to explain its reasoning before it does anything, so we can kind of see its thought
So
process.
it's like a window into its mind.
Exactly. And this gives researchers really valuable insights into how the AI is understanding the task, what options it's considering, and why it chooses to do what it does.
Okay, so that's React. What about C-Act? How does that one work?
C-Act focuses more on, connecting the AI's actions to what it sees on the screen. So instead of just a stream of thoughts, C-Act makes the AI first describe what it wants to do, including saying what element on the screen it wants to interact with. And then it tells us the actual command to carry out that action.
So it's saying what it wants to do and then how it's going to do it.
Exactly. And this helps us understand, is the AI actually seeing the right things on the screen? And are its actions making sense for the task? It's another way to make it more transparent.
Gotcha. So did these frameworks actually help?
Yeah, they did, especially React. When they used React in the text-based mode, some of those top-performing AI models got even better.
So thinking before acting really made a difference.
It seems like it. C-Act, on the other hand, well, the results were a bit mixed. It did help sometimes, but not as consistently. And the researchers think this might be because understanding images, it's just harder for AI than understanding text.
Yeah, visual stuff is definitely more complex. But even with the mixed results, these frameworks, they do seem pretty promising for the future of, explainable AI.
I agree, they're a big step forward, but, like with any new technology, there are trade-offs.
Right. What are some of the downsides?
The main one is that it takes a lot more computing power because these frameworks need the AI to produce a lot more text. It's like asking the AI to write a whole essay explaining every decision it makes.
Instead of just giving us the bullet points.
Right, so we get all that helpful explanation, but it comes at a
It's
cost.
always a balance, isn't it?
It is, and I think that as research goes on, we'll find ways to make these frameworks better.
It's exciting to think about a future where AI is not just capable, but we can also understand it. It feels like we're on the edge of something big, something really transformative.
Yeah, I agree. The progress we've seen in just the last few years, it's amazing, and it's only getting faster. I think we're going to see some truly incredible AI agents in the very near future, ones that are going to make our technology a lot more helpful and fun to use.
And on that note of exciting possibilities, I think it's time to start wrapping up this deep dive. We've covered a lot today. We talked about AndroidLab, those clever ways of measuring how good the AI is, the rise of open source AI, and of course the whole idea of making AI that we can understand and trust.
It's been a great conversation, and I hope everyone listening learned something new. It has been. We went from AI having trouble with screen size to talking about them as partners.
Right. But before we get too far ahead of ourselves, let's come back to reality for a minute. How could all of this actually affect our, daily lives, like in the near future?
Well, think about all the little things that you have to do every day. Managing your calendar, booking appointments, emails, even just ordering groceries. Imagine if your phone could do all of that for you.
Okay, I like where this is going. No more spending hours on email.
Exactly. And we also talked about open source AI. If that becomes more common, well, that could let people create their own agents.
So not just something that the big tech companies control.
Right. Imagine if everyone could have AI that was specifically designed for them.
That would be amazing. It would be like AI for everyone. But we also talked about some of the challenges, like how expensive those explainable AI frameworks are.
Yeah.
What other problems do researchers need to, figure out before this stuff becomes mainstream?
One big one is robustness. Right now, these agents do pretty well in a controlled environment, like AndroidLab, but the real world, well, it's unpredictable.
Lots of things could go wrong.
All the time. Pop-ups, apps crash, internet goes out. These agents need to be able to deal with that.
So they need to be able to think on their feet.
Exactly. We need AI that can adapt. And of course, we can't forget about security. I mean, if we're going to give these agents access to our data, they need to be secure.
That's a big one. How do we know they're safe from, hackers and stuff?
Yeah, security is super important, and researchers are definitely working on that, like encrypting data, making sure communication is secure, and even using AI to detect threats.
So there's a lot of work going on to keep things safe.
Oh, yeah, absolutely. Even with all of the challenges, I'm still optimistic. This feels like the beginning of something really big.
Me too. I think we're on the edge of something amazing. It's an exciting time to be following this technology.
Absolutely.
And to everyone listening, thank you for joining us on this deep dive into the world of AI agents. We hope you learned something new, had some fun, and maybe even got inspired to come up with your own ideas about the future. Keep exploring, keep questioning, and keep those brains buzzing. Until next time.